This is the bare essentials of pre-stressed concrete, a series created to help people that work in construction better understand the theory which governs how pre-stressed concrete works as a material and how we use it on a construction site. Asking the questions for you is this group of people who are either construction professionals or students, and answering the questions will be Dr. Chris Burgoyne of the University of Cambridge.
Pre-stressed concrete is used in a wide range of structural applications, from long-span bridges with multiple spans to precast floor elements in many buildings. I can illustrate this by looking at trying to pick up a block of books. So if I try and pick up the books ordinarily, I find that they will slide over one another. But if I apply an external force, I can then pick up the books as though they were a single beam. If I choose to pick up a bigger pile of books, so I can add some more books to the end of this, then I can still pick them up, but now because the books are heavier, I've got to apply much more force to lift them up. And this is the basic principle by which pre-stressed concrete works. We apply an external force to the concrete that enables it to carry loads in bending.
So what's the difference between pre-stressed concrete and reinforced concrete?
Well, one of the problems we face with concrete is that it has no tensile strength. And when we build a structure which has got a beam in bending, we're going to get tension somewhere in the beam. And we've got to work out how we can actually carry that tension in a material that doesn't want to do it. One way of doing that is to make reinforced concrete. And we put reinforcing bars embedded into the concrete, and the reinforcing bars carry the tensile stresses. But the alternative, as we showed with the books, is that by putting the beam into compression, we therefore eliminate the tensile stresses. And this is the way pre-stressed concrete works. We can eliminate the tensile stresses, and allows us to carry heavy loads in the middle of the beam.
What is the advantage of pre-stressed concrete over reinforced concrete?
Pre-stressed concrete has got a number of advantages over reinforced concrete. One of the problems in reinforced concrete is that the steel is in tension, and the concrete next to it is also in tension, which causes the concrete to crack. That has disadvantages because it allows access for moisture to get to the reinforcing bars, which might cause the reinforcing bars to corrode. It's also unsightly, and even though engineers might know that it's not a problem, the public does not like seeing structures that have cracks, however fine they are. We can eliminate those cracks in pre-stressed concrete by providing the compression so that there are no tensile stresses. And that's the primary advantage of pre-stressed concrete, is to eliminate the tensile cracks that form in reinforced concrete. The second advantage of pre-stressed concrete follows from the first. Because there is no cracking in the section, it means that the whole of the section is involved in carrying the load. This means that we can carry higher loads or carry them over longer spans than we can with a reinforced concrete section of the same size. The third advantage of pre-stressed concrete is material efficiency. In reinforced concrete, the concrete in the cracked zone is really just holding the steel in the right place. And this has the disadvantage that we have to carry its weight, but we don't get any advantage from its strength. In pre-stressed concrete structures, the whole of the section is effective, and therefore it's much more efficient. And so, in summary, pre-stressed concrete has got three advantages. The structures don't crack, they're therefore stiffer, and they use the materials more efficiently.
So why don't people use pre-stressed concrete all the time?
Pre-stressed concrete does require the use of specialist equipment. This can be expensive. You have to allow space for it on site. It requires a higher skill level, and sometimes the equipment can be unwieldy. Reinforced concrete is more versatile and is often perfectly adequate.